Good morning. Today we'll be learning about matrices. What is meant by matrices is representing the numbers in the form of rows and column. Like here, these are the rows. Horizontally what we write are the rows and vertically what is written are columns. So when we show any numbers in the form of rows and columns, okay, that is called as a matrix. Now there are different types of matrix. Okay, like here the number of rows and columns are not same, so it is a rectangular matrix. Another important thing to know here is about order of matrix. Order of matrix is always written with rows into column. If we look at this matrix, there are two rows and there are three columns. So the order of this one becomes 2 into 3. Now we look at the next matrix, which is a square matrix. The rows and columns are both same, two rows and two columns. So whenever rows and columns are same, they are called as square matrix, and this will have an order 2 into 2. Now in this matrix, if you see, there are only one row. If there is only one row, then we call it as a row matrix, and this one will have an order of 1 into 2. Then we have the next one. If you see this one, it has got only one column. So it will be called as a column matrix, and the order will be 2 into 1 because there are two rows shown. Okay. Then we have another matrix. It is a square matrix, and the diagonal numbers will always be 1 and the other numbers will be 0. Then it is called as a square as identity or unit matrix. In this part we will be seeing about how matrices are represented. We represent a matrix in the form of Aij, where I stands for the row and J for the column, and a condition linking I and J is given to you as 3i plus 5j. Again I repeat, I will stand for the row, J will stand for the column. And think we are asked to make a 2 into 2 matrix. So for a 2 into 2 matrix, this first location is coming under first row and first column. That is why written as 1 and 1. It means I is 1 and J is 1. In this location, it is the first row, second column. So A1, 2 it is denoted by. So I is 1 and J is 2. In this location, it is in the second row, first column. So that is why your I value is 2 and J value is 1. And the last one is A22. Okay, so because it is there in the second row and second column. Now how do we find the values of them? If I have to find for A11, so here I stands for 1 and J for 1. So in this relationship 3i plus 5j, I write 3 into 1, that is the value of I, and 5 into 1, that is the value of j, and on solving I get it as 8, so which has been put here in the first place as 8. Now for the second place A12, so written A12, so I is 1, J is 2, so 3 into 1 plus 5 into 2 gives you the value as 13. And so in this place we have written here as 13. Then coming to this place A21, so A21 is value we find, so 3 into 2 plus 5 into 1, and that comes as 11, and so it is written here as 11. Now the last place is A22, so to find that A22, 3 into 2 plus 5 into 2, that gives you as 16. So 16 written over here. In this way we find a matrix where it is being given by any relationship, like here it was 3i plus 5j. Today we will be seeing about how to do multiplication of matrices. For multiplication of matrices, you need to follow that all types of matrices cannot be multiplied. I have taken a matrix here A having order m into n, and another matrix B having the order P into Q. Now multiplication is possible only if n equals to P. This n and this P, that is the column of the first matrix, has to be equal to the row of the second matrix. Then only we can multiply, otherwise we cannot multiply. And the resultant matrix which we will be getting will have the order M into Q. M was present as the row of the first matrix and Q was the column of the second matrix. So row of the first and column of the second becomes the order of the resultant matrix. Now how do we multiply? For that I have taken first matrix here as with the order 2 into 2 and the second matrix with the order 2 into 2. So here it is matching, that is the column of the first is equal to the row of the second and the resultant matrix will be of the order 2 into 2. Okay. So we have in this first place is actually first row and first column. So first row A and B will be multiplied with the first column P and Q. So A into P is AP and B into Q is BQ. Between them there will be a plus sign. Then this location is first row second column. So first row will be taken from here multiplied with the second column R and S. So A multiplied with R plus B multiplied with S, you get this place value. Now in this place when we come, it is your second row first column. So second row is C into D and your first column is P into Q. So that's the way we get C into P plus D into Q. And the last location is second row second column. So the second row multiplied with the second column C into R plus D into S, you get this one. Now second example for multiplication. First matrix is of the order 2 into 2 which I have written here and the second matrix is of the order 2 into 1 which I have written here. So you can see that the column of the first matrix is equals to the row of the second, that is why multiplication is possible. And the resultant matrix will have the order 2 into 1. Okay. So now we multiply. So 2 into 1, it means we need to fill up this place and this place. So now this place has a location first row and first column. So first row multiplied with the first column A into P plus B into Q, that takes care of this first row first column. This one is your first row second column. So second row first column. So second row is CD and column is PQ. So it takes we multiply, so we get CP plus DQ. That's the way to multiply. Thank you.